Hello ladies and gentlemen, we're going to do 8.2 today. We're going to start graphing some simple rational expressions. We're going to explore their graphs, and then we're going to find the vertical and horizontal asymptotes, and then we're going to do some sketching by hand. Alright, so the first thing that I want to define is a rational function. Okay. Alright, so a rational function is a function that is another function on the top divided by a function on the bottom. Okay, and I'm going to know that p of x and q of x are going to be polynomial functions. So I'm going to have a function divided by a function. Okay, so if we talk about for a moment our inverse variation equation. Okay, so that one was y is equal to a over x, and that's what we've just done for the last day. Okay, this is actually a rational function. Okay, so remember the numerator is my constant of variation, and so it's a number, so technically it's still a polynomial function. And I'm going to put an a so you know I'm talking about a. It is a polynomial function with a degree of 0, and then the x is another polynomial function, and it has a degree of 1. Okay, so even though it doesn't really have a function in the top, it is a polynomial function. Alright, so now let's talk about rational functions graphs. Functions graphs. Okay, we call rational functions hyperbolas. Okay, and we'll talk about hyperbolas more later in the year when we talk about conic sections, but it is also called a hyperbola. The parent function, sorry I can't write, is going to be f of x is equal to 1 over x. So notice that the 1 is still a polynomial, but it's a polynomial of degree 0, and then x. So if you'll notice, when you graph this on your grapher, we're going to be doing some by hand, I can't have a 0 in the denominator. So what that does is it creates a vertical, let's see, asymptote, weird word. We're going to label them as a VA, and we're going to write it as an equation, x is equal to 0, because all asymptotes are an equation. It also has a horizontal asymptote. Okay, so it has a horizontal asymptote, MPT, at y is equal to 0, so we would say that the horizontal asymptote HA is going to be y is equal to 0. And so we've talked about asymptotes already, but an asymptote is something that a line is not going to cross, at least at this point. Okay, it pushes curves and does cool things to them. So for this graph, it's actually going to look like this and like this. These two guys, this one, and I'm just going to circle them so you know which ones I'm talking about, and this one are called branches. Okay, the circles have nothing to do with the graph, it's just how I'm identifying it. And so this is what the graph of a rational function looks like. Our task is going to be always to find the vertical asymptotes and then our horizontal asymptotes, put those on our graphs, and then label it. So remember, and I'll just give you kind of a more precise definition of an asymptote. Okay, it is something, and technically it is a line that a graph approaches but cannot cross. Okay, so it's going to get really close, it's going to get infinitesimally close, but it's never actually going to cross the asymptote, at least for right now. Okay, the vertical asymptote is always going to come from the denominator. So I'm going to write comes from the denominator. And our horizontal asymptote we will talk about more later. So I'm just going to write more later, because it actually has a series of things that we use to describe what the horizontal asymptote is going to be. All right, so let's do some examples, and then let's do some graphing by hand, okay? All right, so here's just some examples of some vertical asymptotes, okay? So let's say I had the graph y is equal to 6 over x. I look at the denominator and I want to know what makes the denominator, sorry, I can't spell, be 0. Because if the denominator is 0, the world explodes. So in this particular case, my vertical asymptote is just going to be x is equal to 0. Okay? I don't have another polynomial in the top other than the 6. So my vertical asymptote is x is equal to 0. My horizontal asymptote is going to be y is equal to 0. So this line right here is y is equal to 0. This line is x is equal to 0. My function is positive, my numerator is positive, so my branches still do the first and the third quadrants, okay? And later we'll do some graphing in your calculators, all right? Okay, so now what I'm going to do is have another equation. So what if my next equation was something like 3 over x minus 1, okay? Sorry, it's kind of not centered. Well, my vertical asymptote is always going to come from the denominator. So in this one, I set it equal to 0, so it's going to be x minus 1 is equal to 0. So x is equal to 1 is going to be my vertical asymptote. I don't have a polynomial up here yet, okay? So I'm just going to worry about my vertical. My horizontal asymptote is going to happen at y is equal to 0 because I don't have anything else to change what's going on. So if I graph this at x is equal to 1, then I draw a dotted line. So that's a 1. I'll put that so it looks more like a 1. You always have to draw the asymptote as a dotted line unless it's on an axis. And then this one is y is equal to 0. My graph is still positive, so my graph is going to look like this, and it's going to look like this, okay? So notice that it's trying to get closer and closer and closer to the 0, but it never quite does. And it's trying to get closer and closer and closer to the 1, but it never does either top or bottom. So let's actually take a break and talk about the domain, okay? So remember that domain is my x values, okay? And in this particular graph, it's a discontinuous graph, meaning it's not one smooth curve, because I have a vertical asymptote. This creates a break in my graph. So I would say that the domain goes from a negative infinity to 1. The 1's not included because it's never going to cross the 1. And then it starts at 1 again, still not included, and goes to positive infinity. So that would be my domain. My range, which are the y values, remember we read the range from the bottom up. So it's going to start at negative infinity, and there's going to be a break at y is equal to 0. And then it's going to start here and go forever up. So my range would be negative infinity to 0 unioned with 0 to positive infinity. So our ranges and domains are going to become more entertaining. All right, let me do one more example of a graph. Okay, so this one is going to be y is equal to 7 divided by x plus 2 and x minus 3. Since we find our vertical asymptotes by what makes the denominator 0, and this is already in factored form, I know that x is going to equal 0 when, the denominator, when x is a 3 and a negative 2. So this time, my vertical asymptotes, there's actually going to be 2 of them. I'll put them in negative to positive order. My horizontal asymptote, I still don't have a first degree or higher in the top, so it's still going to be y is equal to 0. So if I graph this by hand, okay, put my little arrows on the ends, I have a vertical asymptote at a -2. You always have to label things. And then I have a vertical at 3, and I'm going to put in my vertical asymptote. So this is x is a -2, this is x is 3, and then this is my y is equal to 0. Now I would put this in my grapher, being careful with my parentheses, and I'll show you how I do it in a minute, but I would use my grapher at this point to help me locate my curves. And my curves are going to do something like this, which is way cool. Okay, so let me show you how I would put that in my calculator. So let me bring my handy dandy grapher in, okay, just so you can see. And I'm going to enter that equation, and I'm going to clear what I have. So I'm going to do 7 divided by parentheses, and then I'm going to do x plus 2, and then I'm going to do x minus 3, close, close, and then I'm going to do a zoom 6. Okay. Now, on some of your calculators, it will actually show you a vertical line, which is the asymptote, but we never include those as a solid line on our graph. An asymptote is always shown with a dotted line. The problem with some of these calculators is I can't see the asymptotes on my graph, but if you look and kind of go tangent, you would know that there's one over here, and I would know that there's one right here. So we will actually find our asymptotes algebraically most of the time. All right, so now as we continue, let me pause for just a moment and clear out my computer because it's being stupid. Okay, so I'm going to come to here, I'm going to close it. Thank you for being patient. Yes, I want to do that. I'm going to bring you back up. All right, and I'm going to go to here. Okay, so now we're back in business. Alrighty, so is everybody good? So now I want to talk about our horizontal asymptotes because they are a little bit more entertaining. Okay, so now we're going to talk about our horizontal asymptotes because there are several different rules that we have to use to find our horizontals. So I'm going to give you the rules first. The first rule says if the degree in the denominator is higher, meaning it's higher than the degree of the numerator, then the horizontal asymptote is going to be y is equal to 0. Okay, and this is something that you are just going to have to memorize. Number 2, if the degree in the numerator and the denominator is the same, then the horizontal asymptote is the quotient, which means divide, of the two leading coefficients. So I'll show you what I mean. So if I had a rational expression and I had 6x plus 3 over x minus 1. Notice that the degree in the numerator is 1 and the degree in the denominator is 1. 6 is a leading coefficient and 1 is a leading coefficient. So my horizontal asymptote is going to equal, or going to be, y is equal to 6 divided by 1, which is 6. So I'm going to have a horizontal asymptote. Okay? Alrighty. Let me actually show you what this one would look like. Okay? Alright. So I'm going to write this, brain and mouth aren't working. That's what happens when it's Friday. I'm going to find my vertical asymptote first, and it's going to be at x is equal to 1. So this is a 1, and I'm going to draw my vertical asymptote. Okay? And then I'm going to have one at y is equal to 6. Okay, so that's going to be a 6. and this is going to be my y is equal to 6, and this is my x is equal to 1. My numerator is positive, so my branches are going to look like this. Put my little arrows on, and now I'm a happy camper. So that's what my graph would look like. Okay. All right, the other situation is if I have my rational expression written like this. And so we'll talk about what these mean. This would be inverse variation, so this is the constant of variation, it's a number, divided by x, and then I have a constant over here on the outside edge. Well, remember that that is a vertical translation, okay, and we've talked about that for a long time now. But the cool thing is then my horizontal asymptote becomes y is equal to c. All right? So if I had an equation that looked something like y is equal to 7 over x plus 2, okay, my horizontal asymptote would be y is equal to 2. So sometimes they're very nice and simple. All right? So now what I want to do is give you some rules for graphing these by hand. Okay, so I'm going to put rules for graphing, because we will do much of our graphing by hand in the beginning. For graphing by hand. All right, number 1, you always want to find the vertical asymptotes first. So you always want to find your vertical asymptotes. Remember, those are going to come from the denominator. And we often find these by factoring. So yep, that F word just keeps coming back again and again and again. And then we're going to sketch on the graph. We're going to sketch with a dotted line and label as an equation. All right, so if you'll, I don't know, you can't see, but if you'll notice like I did on this one, the first thing that I did was I put my vertical asymptote on. It's a dotted line, and then I labeled it with an equation, and then I put on my horizontal asymptote as a dotted line and labeled it as an equation. Okay. My second step is going to be to find the horizontal asymptote, and remember that those come from our little rules. There's only 2 of them, technically 3 so far. We'll get another couple of rules later, little rules. Okay, and then I'm going to sketch with a dotted line and label as an equation. All right. And then the last thing that we're going to do is put in the branches, okay? And those are my curves. And for the time being, we'll use your graphers for help if we need it. The thing that I will tell you about putting rational expressions in your calculator is that you have to put the entire denominator in parentheses. Otherwise, your graph will not be, your grapher will do what you told it to, but that won't be correct. All right, so let's do some examples, okay? All right, so my first example, sorry, don't have my paper in the right spot, is going to say graph, and then we're going to state the domain and the range, okay? So we're going to spend a lot of time talking about domain and range in this particular chapter. All right, so my first example, -4 over x plus 2. This negative is going to change the location of our branches. So if you'll remember, the standard graph, the branches are in the first and the third quadrants. But when it becomes negative, now my branches are going to live in the second and the fourth. Okay? All right, so the first thing that I'm going to do is I'm going to find my vertical asymptote. And from the denominator, I'm going to get x is equal to a -2. And I did that by setting it equal to 0 and solving. So x is equal to a -2. Okay? My horizontal asymptote, I don't have a first degree in the numerator, so it's going to be y is equal to 0. Now I'm going to put that information on my graph. My vertical asymptote was at a -2, and I'm going to draw my dotted line. My horizontal asymptote, oops, I forgot to label it. My horizontal asymptote is y is equal to 0. My negative means that my curves are going to be in the second and the fourth, okay? And for right now, this is all we have to put on our graph. Later, we will label like the y-intercept and other things, but for right now, that's all we have to do. So now let's talk about the domain. Notice that my graph starts over here at -infinity, and it cruises until it hits a -2, and then it stops. And then it starts again on this side of -2, and it goes to positive infinity. So my domain would be written, remember we always start on the left, -infinity to a -2, not included, unioned with a -2 to positive infinity. So remember with domain, we always read left to right, and I write left to right. Okay? Now let's do our range. Remember, range is read from the bottom up. Okay? All right, so this one starts at -infinity and it stops at 0, and then it starts on the other side of 0 and goes up forever. So my range is going to be -infinity to 0 unioned with 0 to positive infinity. And then I would have completed that information. All right, let me just give you kind of a generic set of formulas for our translated rational expressions, because we're going to start off with them fairly simple. They get more entertaining as we go, but we're going to start off pretty simple. So I'm going to have the generic equation a over x minus h plus k. My vertical asymptote is going to be x is equal to h. My horizontal asymptote is going to be y is equal to k. If a is positive, then my branches are going to be in quadrants 1 and 3. If a is negative, then my branches are going to be in quadrants 2 and 4. Alrighty, so that's kind of my generic information. Alright, so now let's do another example, okay? And I'm just going to do several graphing examples. Okay, here's our next one. Just get my paper up. All right, I want you to graph and then state the domain and range. So they're all going to have the same directions. Your equation is going to be y is equal to 8 over x minus 5. So again, I always start with my vertical asymptote. It's going to be x is equal to 0 because there's no translation. My horizontal asymptote with the equation in this is going to be y is equal to a -5. The 8 is positive, so my branches are going to be in the first and the third. So x is equal to 0. I don't have to draw a dotted line because it's actually the axis. And then y is equal to a -5. Remember, you always have to label your graphs with numbers, otherwise they are irrelevant. My graph is going to be in the first and the third quadrants. Those two lines push my curves. So here's my first and my third quadrants, and there would be my graph. The domain of this, x is where I have a break, so it's going to go from -infinity to 0, unioned with 0 to positive infinity. And my range is going to go from the bottom to a -5, and then it stops. It starts again on the other side of a -5, and it goes to positive infinity. Okay, so there's that one. All right, let me do another example. Okay. All right, this time I'm going to do the same directions, graph, state the domain and range, but my equation is going to look a little bit different. So it's 2x plus 1 over x minus 3. Again, I always start with my vertical asymptote. It comes from the denominator, so I'm going to do x minus 3 is equal to 0. So x is 3, that's my vertical asymptote. Because the degree in the top and the bottom are the same, my horizontal asymptote is going to be y is equal to 2 divided by 1, and I'm using that 1 because I'm dividing the leading coefficients. So my horizontal asymptote is going to be y is equal to 2. So if I graph this information, okay, my vertical is at 3. You have to put values on your graph, otherwise your graph is irrelevant. Label that line, x is equal to 3, and then I have one at 2, and this is going to be y is equal to 2. And then these are the two vertical and horizontal lines that push my graph. So it's going to go from there, and then it's going to go there. Okay, so that's kind of cool. It looks a little bit different. So my domain breaks at 3, negative infinity to 3, unioned with the other side of 3 to positive infinity. My range starts at the bottom, negative infinity, it stops at 2, and then it starts the other side of 2 and goes to positive infinity. Okay? So that actually wasn't so bad. Alrighty, so we're just about done. Let me give you your problems. Make sure that when you sketch your graphs that you label everything that I've been labeling. Okay? So I want you to, in all of these problems, I want you to find the vertical asymptote and the horizontal asymptote. I want you to graph, and I need you to label well. Okay? And then I want you to state the domain and range. So the domain and range. All right, so for number 1, your equation is going to be y is equal to 10 over x. Okay? Number 2, your equation is going to be g of x is equal to a negative 3 over x. Pay attention to the negative. Problem number 3 is going to be y is equal to 10 over x plus 7 minus 5. And then problem number 4 is going to be f of x is equal to 6x minus 1 over 3x minus 1. Alrighty, those are your problems. Good luck with those, and I will see you tomorrow.